Jen Kay, and I'm an assistant professor at the University of Colorado here in Boulder. I'm in the Department of Atmospheric and Oceanic Sciences here on campus, and my specialty is clouds, and I also work a lot in polar regions of the planet. So, the North Pole, the South Pole, frozen oceans, ice sheets, snow, lots of crazy things happening up there, and lots of interesting things related to our changing climate. So an example of a project I'm working on is looking at how clouds are responding to Arctic sea ice loss. And that ice is really disappearing as the planet is warming. And so some of the research that I do really asks, well, how does the lower atmosphere, and in particular clouds, respond to that change in sort of the phase of the ocean? So a climate model is just a set of equations, a lot of equations. The big computers that are used to solve the equations that comprise a climate model are called supercomputers. And climate models, they really consist of a number of different components. So they have an atmosphere and an ocean and a land. Again, just lots of equations describing how the processes in each of these components work. And these components, they all talk to each other, which is a really important part of a climate model too, because the atmosphere model has to talk to the ocean model, and they all have to communicate in order to get a coherent story together for what the climate of the planet is. So the sun is giving us a certain amount of heat. We have a certain amount of little particles in the atmosphere. We have a certain amount of greenhouse gases in the atmosphere. Let's say we just hold all of that constant. The climate is still going to vary. There's still going to be years that are a little warmer, years that are a little colder, and that's just because the climate system is chaotic, and there's some aspects of it that will just always be variable. So when you have this constant climate, though, you can change what we call the forcings. So you can change the amount of greenhouse gases in the atmosphere, or change the sun, change how many little particles there are in the atmosphere, and all of these things will change the climate. So I think an important thing to emphasize is that when you have climate change, you still have climate variability. So, you may have more record highs in a climate with more greenhouse gases, but you're still going to have those record lows on occasion because of the variability that's a part of the system. And what's happening now is we're changing the Arctic sea ice, so it's melting in all months of the year, but especially in the late summer. So we're actually really changing the character of the heartbeat of the Arctic as we go into a warmer climate, as a consequence of increased greenhouse gases in our atmosphere. So responding to climate change and some of the changes that we're observing is something you can do in a number of different ways. One is just to adapt. I think it's important that we figure out how to adapt, because some of the climate change that we're seeing, we really have to respond to now. But I think it's also important to think about ways to stop climate change and to stop the warming. And so how do you do that? Well, on a local level, you can be more energy efficient. So you can ride your bike instead of driving your car. You can, turn off the lights when you're not using them. You can make sure that, the faucet isn't leaky, because, water in some sense has a lot of energy associated with it. So when you conserve water, you're also conserving energy. These may seem like small things to do just around the house, but the power of these things is really when you scale them up. And if we all do our part, then we really do and can have a substantial influence on the amount of greenhouse gases in the atmosphere. Another thing that I do is I vote. And I vote for people who know about the global implications and know about the challenge of this problem, and know that we have to work together with people all over the world to figure out how to reduce our greenhouse gas emissions, so that we don't end up in a situation where we have a planet that becomes sort of uninhabitable, or not as great a place for us and also for the rest of nature.